So now say Octave is kind of very simple. You can create a variable just like this. Say for example a is equal to 5. So that's it. So a, if you again just write a and press enter, you will get a is equal to 5. If suppose you want to give, instead of one value you want to have a vector, then you can write it something like this. Say b is equal to 1 2 3. So this is a vector. Enter. So now b has a vector. b is a vector 1 2 3. So you can now if suppose you want to have some matrix, let us say m, then that can be given as 1 2 3. This is first row, semicolon. That means here the first row ends, 4 5 6, second row ends, and anything 7 8 9, third row. Done. So now you get 1 2 3 4 5 6 7 8 9. Or you can even write it like this, it doesn't matter, 1 2 3, and instead of this semicolon you can just press enter, and then second row you can write 4 5 6, enter, 7 8 9, and then complete, enter. So this way now you have m as a vector, m as a matrix. So this way you can actually write down your variables a, b and m. And again, if you want to say, let us say you want to take transpose of m, so m dash will give you m transpose. Or if suppose you want inverse of m, you can take inverse and then m. Now this will give me error because there is singularity problem, so that's why this is it. But if suppose matrix is proper, then you will get a proper inverse of that matrix. If suppose you want to find out matrix m in use, let us say something, now we have vector b. Okay, so m b dash it needs to be a vector, so b transpose. So this matrix into a vector and you will get the solution. So m times b is some other vector. So and this I can assign it to something like say c is equal to m into b transpose. So this way I can use variables and I can store the variables and I can use them again later on in my calculation. So now if I let us say c into 4 or 5, then whatever this c vector was, that is multiplied by 5 over here. So it's very simple, fairly simple here so far. Now we will directly go into, of course there are many things that I need to explain for Octave, but this is not the time or this is not the place for explaining those things, so you need to learn them on your own. What we are going to do is we are directly going to solve the problem at our hand, that is how to solve a single degree of freedom system using LSODE with Octave. So let us go to the last one more thing that I need to mention, that whatever I have mentioned, whatever commands are executed here, all these commands are executed one by one. If suppose I need to change matrix m, I cannot go here and change the matrix. I have to again write a new matrix m, whatever that new matrix is, and whatever it is, and then again after whatever that calculation I perform, I need to perform that. So instead of doing that, I can write it as a code, like a script, so that I can change everything in whatever I want to change into that script, and then entire code will run as it is. So say for example this editor, let us say m is equal to the same command that I wrote there, 789, and then let us say b is equal to 1 2 3, and I want to find out solution c is equal to m into b transpose because I need to make this b as a column vector, so that's why I have to take its transpose. So now c I have calculated. Let me save this file. Let us say trial1.m. All Octave files will have extension .m. So save. Now I can execute this using this gear symbol, save file and run. And when you execute it, go back to command window and you will see this m is equal to so and so trial 1. From here it has started, m is equal to so and so b and then c. Now if suppose I want to change one value in m, let us say instead of 2 I want to have here 8. So I'll just change that. I will save this file and execute it. So that again now it will have m183. So this value is changed and then change the C, change the solution I have. So this way we can use editor to keep track of our code as well as make changes to our code very easily. So that is what we are going to do now. So now let's directly jump into our actual code.